All right, we are looking at simplifying radicals, in this case, square roots. So the idea is that we want to, if possible, pull out a perfect square and get this down to a whole number. More than likely, most of them won't happen. So we can sort of see what the approximate square root is here to begin with by just typing into our calculator square root of 80. So put that somewhere where we can read it a little bit better. There we go. And it's not a perfect square, right? There's no whole number that goes into this perfectly. So we want to see if any perfect squares go into that number. So we do need to be pretty familiar with what the perfect squares are. Here, I'll pull this down for a second. The perfect squares are the numbers that we get when we square whole numbers. So we start with 0 and we do 0 times 0 is 0. Then we go to 1, 1 times 1 is 1. Then we go to 2, 2 times 2 is 4. 3, 3 times 3 is 9. 4 times 4 is 16. And we just kind of continue that pattern. You could go forever. Well, you can't go forever because there's always another one when we're counting 0, 1, 2, 3, 4, 5, 6 that we can keep squaring. For right now, this should be plenty. They do go on forever. We want to know if any of these numbers go into our radicand, the number that's under the square root, the inside number. So we kind of actually ignore the first two perfect squares. Dividing by 0, 1 you can't do, and dividing by 1 doesn't really change anything. So we really start with 4. We want to find out if 4, because 4 is a perfect square, goes into 80. So we do 80 divided by 4. Oops, there we go. And it does go in there evenly. So instead of 80, we're going to write this as square root of 4 times 20. And the reason that we do that is that we can actually break this down into the square root of 4 and then times the square root of 20. That gives us a 2 out here, a positive 2 times the square root of 20. Now, you'll see that this is the same decimal equivalent. Like if I go back to my calculator and I do the square root of 80, I get this decimal. If I do 2 times the square root of 20, it's the same decimal. So they do definitely equal each other. Now this one, actually, we have to keep going because 4, I know right away by looking at that number 20, my math facts are screaming at me. 4 also goes into 20. So we can actually repeat this process. We'll leave the 2 on the outside. Instead of 20, I'm going to write 4 times 5. And then I break that down into 2 perfect squares. 2 squares, I should say. Only one of them is perfect. This becomes 2 times 2 times the square root of 5. So my final answer here is 4 square roots of 5. And once again, if I type that into the calculator, we can kind of see it there, 4 times the square root of 5, it is the same decimal equivalent. Now you might be looking at that and going, oh my God, that was kind of a long steps. And it was because we had to do it twice. We really only recognized that 4 went into 80, but we actually could have done it faster if we had recognized that 16 also went into 80. Oftentimes, if 4 goes into a number, I try 16. Sometimes I'll even go to the next power of 2 and I'll try 64. Because 4 squared is 16. So we do 80 divided by 16. So you can see here we would have gotten this much faster if we had recognized that 16 was actually the biggest perfect square that goes into it. So instead of 80, we had 16 times 5. And then we would have gotten the square root of 16 times the square root of 5. And we would have gotten 4 square roots of 5. So we could have gotten the answer a little bit sooner if we had recognized 16, but you can get there either way. Times to 4 times the square root of 5 is the square root of 80. It's the simplified version. Now the next one is going to go much quicker because that, as we actually pointed out here, is already a perfect square. There is a whole number when multiplied by itself that will give you 16. The square root of 16 is 4. So this requires very little work to simplify. It is just 4. All right, let's look at the next one here, 75. We are looking to see if any perfect squares go into that number. So again, I'll bring my list of perfect squares down. I can test, like you can just type them into the calculator, 75 divided by 4. It does not go in there evenly, but you may have known that already because this is an even number and that's not. 75 divided by 9, you might have recognized that as well because 7 plus 5 doesn't add up to a number that goes into, that 9 goes into. But I'm actually going to jump to what I know. It's 25. And a lot of you probably know that too, just from your knowledge of quarters, right? 25 plus 25 plus 25 is 75. So 75, I can divide by 25, which means I can create a multiplication problem using one of my perfect squares here with the number 75. So I'm going to go ahead and do that. The square root of 75, it's the same thing as 25 times 3. I can go individual square roots. Square root of 25 is 5. So 5 square roots of 3 is my final answer. And again, the calculator will verify that these two things are equal. The square root of 75 is this decimal, 8.66, and then of course a bunch more. If I do 5 times the square root of 3, you'll see we get the same thing. It is the same decimal equivalent. Okay, so they are equal. That's just the simplified version. You pull out the perfect square factor. All right, square root of 30. So we're going to do the same process. We're just going to find out if any of these perfect squares go into it. And again, I can just make the calculator do that work for me. 30 divided by 4 does not go in there evenly. 30 divided by the next perfect square, which is 9, does not go in there evenly. 30 divided by, what's the next one, 16. 30 divided by 25. And at this point, I passed 30. I'm getting to 36. There's no point to continue to test because there's no way these numbers that are bigger are going to fit in there evenly. So actually what that tells me is that this is done. This is already simplified. It cannot be simplified any further. So the square root of 80 became 4 square roots of 5. The square root of 16 just simplified to the whole number 4. The square root of 75 simplified to 5 square roots of 3. And the square root of 30 is already in what we call simplified radical form. Simplified radical form. So again, the idea is just to pull out the perfect square and then take the square root of that number. We get a whole number on the outside. Hope that's helpful. Message me anytime with questions.